How does a blender motor generate so much power? Imagine blending ice, fruits, and nuts into a smooth drink all in seconds. That's the power of a blender motor at work. But how does this small machine produce such impressive force? Let's break it down. When you plug in your blender and press start, electrical energy flows into the motor. The motor then converts this electrical power into rotational movement. Most home blender motors use between 300 and 800 watts of power, while commercial models can go over 1,000 watts. That wattage tells you how much electrical energy the motor consumes and turns into mechanical force. Inside the motor is a single-phase, alternating current motor that spins at extremely high speeds, around 13,000 revolutions per minute. Some high-end models can spin even faster. This high speed is what creates the power needed to blend tough ingredients. The motor has a drive shaft made from toughened stainless steel, with special splines that connect tightly to the blade assembly. This connection is designed to handle the extreme speeds and forces involved. High-speed carbon steel bearings support the shaft, allowing it to spin smoothly without too much friction. When the motor spins, it drives the blades inside the container at speeds of about 300 kilometers per hour. That's faster than a jet engine. The blades turn roughly 18,000 times every minute, pulverizing ice and blending ingredients into a smooth mixture. The power transfer from motor to blades is direct. The motor's shaft extends upward and connects directly to the blade shaft inside the container. When you turn on the blender, the motor spins the shaft, which then spins the blades. This direct connection minimizes power loss and makes sure the force is transferred efficiently. To handle the intense forces, blender bases are made heavy and stable. The weight keeps the machine from moving or vibrating during operation. High-speed bearings help the shaft spin freely at maximum RPM, and rubber rings protect plastic parts from metal contact damage. Electronic controls also play a role. They include components like potentiometers that let you adjust speed and capacitors that regulate voltage and reduce electrical noise. These systems help the motor run smoothly and deliver consistent power to the blades. The motor's ability to generate power depends on both its RPM and torque. RPM shows how fast it spins, while torque is how much force it can produce to handle dense ingredients. When blending tough foods like frozen fruit or nuts, the motor may slow down slightly, but its torque keeps the blades turning without stalling. The combination of high wattage, extreme RPM, and smart mechanical design makes blenders capable of handling many tasks. A lower wattage blender, around 300 watts, can make smoothies with soft ingredients. But for crushing ice or grinding grains, you need a higher wattage motor. In the end, a blender motor is a clever mix of electrical, mechanical, and electronic parts working together. It takes a modest electrical input and transforms it into the powerful force needed to blend, crush, and puree all kinds of ingredients. The engineering behind the drive shaft, bearings, and motor design ensures this power is delivered safely and reliably, making your blender a true kitchen powerhouse.